to practice using Lenz's law, and we want to know if there's any current that's created by a changing magnetic field or magnetic flux going through the loop. So we look in this example here, we're looking at the magnetic field, and that's represented by this rectangle. And inside this rectangle, we have 6 dots, and those dots are representing the magnetic field coming out of the page. So out of the page is the magnetic field in this example, into the page is the magnetic field in this example. So let's start with the A. And here I'm just going to check my pen, make sure it's working, looks good. So here I've got my loop, and I start off with 4 lines of magnetic field, or these 4 dots represent the magnetic flux before, and then after, if I draw another loop of wire, right, and as I pull it out, I'm only going to have, say, 2 lines of magnetic flux going through this loop. So I have less magnetic flux going through it, and what the current that is induced wants to keep the status quo. So it wants to have 4 lines of magnetic flux going through it. So what it does is it wants to generate more magnetic flux. And in order to create a magnetic field coming out of the page, right, if I put my thumb towards me and my fingers curl in the direction of the current, then that means that my current's going to go this way, or counterclockwise, because a counterclockwise current will generate magnetic. So a counterclockwise current represented by my curling fingers, and then the magnetic field lines are represented by my thumb, and that's pointing at me. So that tells me the B field's coming out of the page. Let's try the next one. So here my before picture is this loop, and I have 3 field lines going into the page. So my B field is into the page. So we'll call this B in. And after, my loop is a lot smaller, and it only has 1 field line, right? And so what my current wants to do is it wants to have the same amount of field lines, so it wants to have these 3 field lines. And so in order to create those field lines, I need to create a current that's going to generate a magnetic field into the page. So I can point my thumb into the page and curl my fingers, and the curling of my fingers tells me that my magnetic field, or my current, is going to go clockwise. Okay, so the next one. Okay, in this example, I have a magnet, and the magnet, if I think about this, I've got a magnet. The south end is closest to me, and the north end is closer to your screen. And they're both out of the page. So there's the loop in the page, and then the magnet is out of the page, and the magnet is moving towards the loop. So if I draw this from the side, let's see, I'll draw a magnet. Here's my south side, here's my north side, and then here's my loop. And let's call this side closest to me. So this magnet has magnetic field lines, right, that look like this. And then they start to spin around here. And so the field lines, there are field lines here, and they're, because I'm further away from the magnet, my flux or magnetic field is smaller than it is as I get closer. So as I bring my magnet closer to the loop, more magnetic flux is going through this loop. So what that looks like is just that I've got these magnetic field lines here. And let's just say this magnet, in this configuration, we have 3 magnetic field lines to start. And then as I bring it closer, here's my magnet, north, south. As I bring it closer, so now I've got my loop that looks like this. Let's say now I captured a lot more magnetic field lines, like let's say 5. Well, what the loop says is, hey, I want to go back and I want to have the same magnetic field lines that I had before, so it needs to create a current. And the current that it creates is going to create a magnetic field to offset some of these extra field lines that it has. So it's going to create it wants to create a magnetic field going this way to the left. And in order to do that, it needs to create a current, and that current would be going up this side of the loop and down the other side. And so what does that mean? Well, over here, I know that going through the loop, right, it's going to the right. So here it's going to be going into the page. My north is creating these magnetic field lines into the page. And so if I have start out with 3, and then when I get closer, there's 5 more, then I need to create some magnetic field out of the page. And so out of the page tells me that my current is going to need to flow this way. So my current is going to flow counterclockwise. Let's go to the next one. In this example, what's happening is I have this loop and I can rotate the loop. I can rotate it around this central axis. So I start off with, at the start, with my magnetic field parallel to the face of the loop. So if that's true, then no magnetic field lines actually go into the loop, right? My loop is lined up so that no magnetic field lines can go through it. And then as I rotate it, then magnetic field lines can go through it. And so I start off with no magnetic field lines through it. And then as I rotate it, more magnetic field lines. So I start off like this with nothing. And then as I rotate it, what happens is I have magnetic field lines going into the loop. So like this, say. And so I start from 0, and then all of a sudden I have 3. Well, what does this loop want to do? Well, it needs to create magnetic field going into the page. And so that means that my magnetic field is going to be counterclockwise. So I'm going to say counterclockwise. And so if we just want to review these, I think we must have forgotten this one. So this one, I've got my magnet and I have my loop. And remember that my magnetic field is created by my magnet, and it's going to point like this. Right, that's going to be my B field. But nothing's happening to my loop. Like, I'm not rotating it. So there's no field lines going through my loop. And just because I'm moving the magnet, I'm moving the field lines. But since nothing's going through it, I have a 0. So that D is going to be this 0 current. I haven't created any current because I'm not changing the magnetic flux through the hole in that loop.